In this video, we're going to talk about writing and balancing chemical equations. So there's several parts to a chemical equation that you're going to want to be familiar with. On the left side of the equation, you're always going to have reactants. So these are the substances that you're starting with. You will then have an arrow that stands for yields or makes or produces, whichever of those phrases you'd like to use. And then on the right hand side, you'll have products. So those are the substances that are produced or made after the chemical reaction occurs. You can have more than one reactant, more than one product. So if you have more than one, a plus sign is used in between. So A plus B makes AB. So this would be a single substance A reacting with another substance B, making one substance AB. Those are just some examples. The order of reactants and products does not matter, so I could have written this as B plus A makes AB, and there's no difference there. That part does not matter. It's also common to use subscripts for states of matter. So S for solid, L for liquid, G for gas, A for aqueous, meaning it's dissolved in water. So as an example, A is a solid substance reacting with B, that is a liquid, creating AB, that is a gas. So I'm just making this up, but if you see those subscripts, that's telling you the state of matter. For a chemical equation to be considered complete and accurate, it does need to be balanced. So balanced means that it has the same number of each type of atom on both sides of the arrow. So this connects back to the fact that you cannot create or destroy matter. All you can do is change it from one type to another. So if I start off with, say, 5 molecules of A reacting with 3 molecules of B, and I say that it only makes 1 molecule of AB, that can't be correct. Because what happened to the other 4 molecules of A and 2 molecules of B? So that would be considered not balanced. If I said instead it was 5 molecules of A plus 3 molecules of B, making 1 molecule of A5B3, there it's balanced. But by putting the numbers inside of the formula, I've changed the substance that's being produced. So it has to be balanced, but what we can't do is change formulas. All we can do is put coefficients, which are, we're going to use big numbers, out in front. So this 5 and this 3, those are coefficients, saying we have 5 molecules of A, 3 molecules of B. So let's get rid of this generic example and look at a real example. So let's say we had NH3 reacting with O2 to make N2 and H2O. So as written, I have 1 molecule of NH3 reacting with 1 molecule of O2 to make 1 molecule of N2 and 1 molecule of H2O. What we need to look at are the individual atoms. So setting up a table on both sides works for a lot of people. Whatever kind of accounting system works for you, that's up to you. So I have nitrogen, hydrogen, and oxygen on both sides of the equation, which is necessary. I can't make new elements from old elements. So the elements themselves can't change, just how they're connected to each other. So currently I have 1 atom of nitrogen on the reactant side. I have 3 atoms of hydrogen, and I have 2 atoms of oxygen. So 1 nitrogen, 3 hydrogen, 2 oxygen. On the product side, I have 2 atoms of nitrogen, 2 atoms of hydrogen, and 1 atom of oxygen. These numbers are not the same. Right? The goal here for balancing is that these numbers for each atom type are the same. So to balance, I'm going to put coefficients, big numbers, in front of each compound or molecule, and that number is going to multiply all of the atoms in that molecule. So just as an example, if I put a 2 in front of NH3, that tells me I have 2 molecules of NH3. So that would be 2 atoms of nitrogen and 6 atoms of hydrogen. So by doing that, I now have 2 nitrogen and 6 hydrogen, like I said. If I look at the product, I already had 2 nitrogen, so nitrogen seems to be good for the moment. Hydrogen's still off, so I now have 6 on the left and only 2 on the right. So to get to 6 from 2, I can multiply by 3. So 3 times 2 gives me 6 hydrogens. That 3 also multiplies the oxygen, so now there's 3 oxygens. If I look on the reactant side, I only have 2 oxygens. So I'm still not there. So to get to 2 to 3, I can multiply by 1.5. So now I have 3 oxygens. I have 6 hydrogens and 2 nitrogens on both sides. So this would appear to be balanced. However, a correct equation will never have anything other than whole numbers as the coefficients. So if you ever end up with a half as a coefficient, but it's otherwise balanced, the quick fix is to multiply all of your coefficients by 2. So if I change this 2 to a 4, the 1.5 to a 3, no number in front implies 1, so we never have to write 1, it's assumed to be 1, but 1 times 2 is now 2, 3 times 2 is now 6. So now if I check my numbers, I have 4 nitrogens, and 4 times 3 hydrogens is 12. So 4 nitrogen, 12 hydrogen. Oxygen, I have 3 times 2, which is 6. If I look on the product side, I have 2 times 2 nitrogen, which is 4. I have 6 times 2 hydrogens, which is 12. And I have 6 times 1 oxygen, which is 6. So 4, 12, and 6. So everything is equivalent, and I do not have halves. I don't have a factor that I can take out, the lowest common denominator. I need the smallest numbers possible. So this would be considered a balanced chemical equation. So let me rewrite it so you can see the final clean answer. So this says I have 4 molecules of NH3 reacting with 3 molecules of O2 to produce 2 molecules of N2 and 6 molecules of H2O. So what I just did on that previous slide was reading a chemical equation. So let's look at another example. N2SO4 plus C yields Na2S plus CO2. So first let's work through and balance this equation. So I have nitrogen, sulfur, oxygen, and carbon on both sides. To start, I have 2 nitrogens, I have 1 sulfur, 4 oxygens, and 1 carbon. On the other side, I have backtrack here a second. Correction. I have nitrogen here, Na here. I can't change substances. This is a typo on my part. This should be Na on this side as well. So what I'm really working with is sodium. Sorry about that. But that's a check, right? I caught myself there. So I have 2 sodiums on the product side, 1 sulfur, 1 carbon, and 2 oxygens. So I'm not balanced. Sodium, sulfur, and carbon is good, but my oxygen is not. So I need to have 2 more oxygen on the product side. So to do 2 more, 2 times 2 would give me 4. But by doing that, now I just increased the number of carbons up to 2 as well. I didn't touch the sodium or the sulfur, so those are still 2 and 1. But by trying to fix oxygen, I messed up carbon because I only have 1 on the reactant side. But that's an easy fix. I can put a 2 in front of the carbon, and now 2 times 1 is also 2. So I have 2 sodiums, 1 sulfur, 4 oxygens, and 2 carbons. So this is now balanced. So now reading. So there's a couple ways you can read this. like I did earlier, this is saying 1 molecule of Na2SO4 reacts with 2 molecules, or in this case 2 atoms of carbon, to produce 1 molecule of Na2S and 2 molecules of CO2. Another way to think about this, and connects to what we've done so far already in this chapter, is to think of this as moles. So before I jump to moles, let's say I could read this as 1 dozen Na2SO4 reacts with 2 dozen carbons to make 1 dozen Na2S and 2 dozen CO2. Okay, I just multiplied everything by 12 and called it a dozen. I could do the same thing with a mole. I could say I have 1 mole of Na2SO4 reacting with 2 moles of carbon to give me 2 moles of 1 mole of Na2S and 2 moles of CO2. So the ratios hold using those coefficients, whether you're talking about individual molecules, talking about a dozen molecules, talking about moles, which is the most common, any of those work. So let's see if we can answer this question. How many total atoms does each of the following expressions, which are taken from some balanced chemical equation, actually represent? So this is the coefficient in front of the molecule coming from some balanced equation. So this is telling me I have 2 molecules of SO3, or I have 2 moles of SO3. Either way. Right now we're talking about individual atoms, so let's just say it's 2 molecules of SO3. So that 2 is going to multiply every element. So there's 2 times 1 sulfurs, so it's 2 sulfur atoms. And then 2 times 3 for oxygen. So there's 6 oxygen atoms. Right, so this is just a reminder that that number multiplies everything for the formula that's in front of. Next one, I have 4 times 2 for nitrogen, so 8 nitrogen atoms. I have 4 times 4 hydrogen, so 16 hydrogen atoms. Pause the video and see if you can do the last 2. All right, I have 3 times 3 hydrogen, so 9 hydrogen. I have 3 times 1 for phosphorus, so 3 phosphorus. 3 times 4 for oxygen, so 12 oxygen. Then this last one, we've got parentheses. So remember again, the number outside the parentheses multiplies the numbers inside. So really I have O3H3. Now this 6 is going to multiply by everything as well. So for aluminum, it's 6 times 1, so 6 aluminum. For oxygen, it's 6 times 3, which is 18 oxygen. For hydrogen, it's 6 times 3, or 18 hydrogen. Okay, so again, the big number, the coefficient in front that's used to balance, multiplies everything in the following chemical formula. Here's some examples for balancing. Now, when you're doing balancing, there's a lot of different ways to do it. Nothing's right, nothing's wrong, other than the rules that you have to follow in the end. Things you have to do, you can only use coefficients, the big numbers. You can't change chemical formulas, so you can't put in subscripts. Where you start doesn't matter. Pick an element, start there. A few suggestions that sometimes are helpful. If you have an element that's by itself, so for example, H2, that element is the only element in that molecule, save it for last. Or same thing with sodium, because if you fix those by putting coefficients in front, you're not going to mess up another element at the same time. That's just a suggestion. Another thing to keep in mind is if you find yourself going in circles, if you fix one thing, it messes up another, you fix it, it keeps messing stuff up, stop, erase, start over, because there's probably a mistake somewhere that's causing that. So let's just look at these. So sometimes just working left to right is the best. Like I said, there's really no right or wrong place to start. Just pick an element. So I have sodium, hydrogen, and oxygen as my 3 elements I'm working with. Currently, I have 1 sodium on the reactant side, 2 hydrogens, and 1 oxygen. Product side, I have 1 sodium, 1 oxygen, and I have 3 hydrogens. So notice I have 1 hydrogen from the NaOH and 2 from the H2. So you have to add all of those together. So sodium and oxygen currently are balanced, however hydrogen is not. I have 2 on one side and 3 on the other. So 2 compared to 3 is a tricky one because you can't real easily make one become the other. So one trick that I suggest is whenever you have an odd number of something other than 1, so for example the 3 hydrogens here, I try multiplying that by 2. For some reason balancing things with even numbers is easier. I don't have the explanation behind that necessarily, but it's something that seems to work more often than not. So I'm going to put a 2 in front of the NaOH. So that gives me 2 times 1, which is 2, plus the other 2 hydrogens for a total of 4. Now I can more easily go from 4 hydrogens on the product side and 2 hydrogens on the reactant side by putting a 2 in front of the H2O, which now also gives me 4 hydrogens on the left side. Now I need to remember that that 2 in both cases multiplies everything in the formula. So I've fixed hydrogen, but now I've created problems with oxygen and sodium. So this is 2 times 1, so now I have 2 oxygens. This is 2 times 1, so 2 oxygens, so that's good. Oxygen is still balanced. But now I also have 2 sodiums on the product side, whereas on the reactant side I only have 1. Easy fix, I can put a 2 in front of the Na. Fixes sodium, doesn't mess anything else up at the same time, so now I'm balanced. 2 sodiums, 4 hydrogens, 2 oxygens, 2, 4, and 2. So that is now balanced. So again, I kind of had to guess check, play around a little bit. This just takes practice. The more of these you do, the more of these little tricks you pick up on. Let's look at the next example. So I have sodium, zinc, sulfur, and oxygen. To start, I have 1 sodium, 1 zinc, 1 sulfur, and 4 oxygens. Product side, I have 2 sodiums, 1 zinc, 1 sulfur, and 4 oxygen. So currently the problem is sodium. Everything else to start is balanced. So to fix sodium, I will put a 2 in front of the Na, which now gives me 2 sodiums, and that's it, I'm done. By putting that 2 in front of the Na, I didn't mess anything else up. Everything else was already balanced, so there is your balanced chemical reaction. Sometimes they are really that easy. So here's a few more. Go ahead and try this first one on your own and come back and check your answer. Before going on to the last 2 though, I'm going to show you the second one and then I'll let you try the third one on your own. All right, NaBr, Cl2, NaCl, Br2. So I have Na, Br, and Cl as my elements I'm working with. So to start, I have 1 sodium, 1 bromine, 2 chlorine atoms, 1 sodium, 2 bromines, 1 chlorine atom. So I need to get bromine up to 2 on both sides and chlorine up to 2 on both sides. Sodium currently is balanced. So to get bromine up to 2 on the reactant side, I would need to put a 2 in front of the sodium bromide. So that gives me 2 bromines, but that also gives me 2 sodiums. Now, if I go to the product side, if I want to get sodium up to 2 and chlorine up to 2, I can put a 2 in front of the NaCl. Now I have 2 of everything on both sides and it is balanced. Looking at the second problem, I have carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen. I have 4 carbons, 8 hydrogens, 2 oxygens. Product side, I have 1 carbon, 2 hydrogens, and 3 oxygens. Again, I've got oxygen in 2 places, so don't forget to add them together. So I'm just going to start with carbon. I have 4 on the left and only 1 on the right, so I'm going to multiply carbon by 4. By doing that, that also multiplies these 2 oxygens by 4, which makes 8, plus the 1 from water makes 9, so that's 9 oxygens. So oxygens are all messed up. Hydrogens are still messed up. Hydrogen looks like an easier fix, 8 to 2. So I can put a 4 in front of the water, which gives me 8 hydrogens on both sides. Now by doing that, I've multiplied this oxygen by 1. So that's 4 oxygens plus the 8 from the CO2 makes 12 oxygen. So now I have 12 oxygen on the product side and only 2 on the reactant side. So if I put a 6 in front of the O2, now I have 12 on both sides. So let's get rid of the tables here so we can more easily see the final answers. So there's your balanced equation for the second one. Again, go ahead and pause and see if you can do this third one. This third one, I can tell you you're probably going to end up with a half number again. Remember, the best way to fix that is if you get it balanced with that half, multiply everything by 2. All right, so again with this one, we have carbon, hydrogen, and oxygen. I have 5 carbons, 10 hydrogens. I have 2 plus 2 oxygens, which is 4. Product side, I have 1 carbon, 2 hydrogens. 2 plus 1 oxygens is 3. So I'm just going to start with carbon. 5 on the reactant side, 1 on the product side. So I'll multiply that CO2 by 5, which gives me 5 carbons on both sides. Hydrogen, I have 10 versus 2, so I can multiply the 2 by 5 to get 10. Now I have to remember, by putting those 5s over here, I've now changed my oxygen number. So 5 times 2 is 10. 5 times 1 is 5. So I currently have 15 oxygens on the product side and 4 on the reactant side. So what am I going to do now? So I don't really want to put anything in front of this number or this compound, because if I do, it's going to mess up carbon and hydrogen, which I already fixed. So I want to only try to put something in front of the O2, because that's not going to mess anything else up at the same time. So I need to remember I have these 2 oxygens here. So I can really kind of think about having 13 oxygens to balance, because I've already taken care of 2. So if I have 13 on the product side, and I'm kind of thinking about having just the 2 I'm focusing on the reactant side, how do I get from 2 to 13? Well, I can take this times 6.5. So now I've got 2 plus 6.5 times 2. So 6.5 times 2 is 13, plus 2 is 15. Product side, I still have the 5 times 2 is 10, plus the 5 times 1 is 15. So currently oxygens are balanced, hydrogens are balanced, and carbon is balanced. But I have this half, and I can't keep that half. So what I'm going to do is multiply everything by 2. So I'm going to put a 2 here. 6.5 times 2 is 13. 5 times 2 is 10. 5 times 2 is 10. So let's recheck our numbers. So I've got 2 times 5 carbons, which is 10. 2 times 10 hydrogens, which is 20. 2 times 2 oxygens, which is 4, plus 13 times 2. So 4 plus 26 is 30. So I have 30 oxygens on the left. If I look at the product side, I have 10 times 1 carbon, which is 10. I have 10 times 2 oxygens, which is 20, plus 10 times 1, which is 10, so a total of 30 oxygen. And what am I missing? Hydrogen, so 10 times 2 is 20 hydrogen. So 10 carbons, 20 hydrogens, 30 oxygens. Okay, so that's very, very messy. Let's rewrite this. 2 of the C5H10O2 plus 13 O2 yields 10 CO2 plus 10 H2O. So there's your final answer. So hopefully the other thing this is teaching you is do these in pencil, right? You're going to be erasing, changing things quite a bit, or have lots of scrap paper to write out your answers.